Welcome back to Aurora Tech Channel. Today, I will be reviewing the Kingroon KP3S Pro, which is an upgraded version of the old KP3S and that is similar to the Prusa Mini. They are both cantilever-style printers where the x-axis is only supported at one side, so they generally have a smaller print volume. The Prusa Mini is a 180 cube and the KP3S Pro is a 200 cube. Let's take a look at the hardware of this printer. It uses linear rails on the X and Z axis, but the Y axis uses rubber wheels. You can order an upgrade kit, but I will talk more about this later. It uses a Titan-style single-gear direct drive extruder with a 3:1 gear ratio, and the hot end is a modified V6 style with a PTFE lining heat break. It has belt tensioners on both the X and Y axis and a color touchscreen. It uses an OEM MKS Robin Nano motherboard with TMC2225 silent stepper drivers on all axes. By default, it comes with a glass bed, but you can pay an extra $10 to upgrade to a smooth PEI print surface. It has no auto bed leveling sensor, so leveling has to be done manually by adjusting the knobs underneath the bed. The retail price of this printer is $209. I would like to thank Kingroon for sending me this machine to review, and with that, let's get started. We have the Z-axis and the X-axis with the print head, the base with the Y-axis, a Z-axis lead screw packed inside this PVC tube, a detached filament holder, the user manual, and some tools. First, I will install 2 T-nuts on the Z stepper motor mount, and then put the Z and X axis on top of the base and secure it with 2 screws at the bottom, 2 screws at the back, and use T-nuts at the Z stepper motor to secure it at the front. Next, install the lead screw and make sure it reaches the bottom of the coupler before securing the 2 set screws. Check the belt tension and tighten it if necessary by turning the thumb screw on the X-axis. Do the same on the Y-axis and tighten the thumb screw if you need to as well. The only cable you need to connect is the X stepper motor. Check the voltage on the power supply and make sure the rubber wheels on the Y-axis are tight enough so none of these wheels can spin on their own. We can now turn on the printer. Remove all the protectors on the screen and the print bed. I will start by homing all of the axes to make sure everything is working. As you can see, there should be something to trigger the Z-limit switch, but it's missing, so the nozzle just crashes into the bed. I then found the screw inside the box, and as the screw is still loose, I believe there should be a spring here too, but I couldn't find it inside the box, so I put a standard spring for the print bed leveling knob, and it seems fine. It works perfectly fine when I home the printer again. As this printer doesn't come with the bed leveling sensor, I will just level the bed manually. In fact, leveling a tiny bed like this is easy, and it should be even faster than doing auto bed leveling. Then, I will start the first print of the sample 3D Benchy G-code inside the micro SD card. The first layer didn't stick well, so I may need to lower the nozzle, but when I tried using the screen to do this, there was no Z offset or baby step option available. So, I will just let it print and see how it looks. Somehow, the front of the Benchy is warping, so I just stopped the print. As you can see, the nozzle is too high, and the first layer isn't squeezing into the bed at all. I just re-leveled the bed and restarted the print. This time it looks much better. The Benchy has excessive stringing, which could be because of the slicer settings or the filament, as I just used the PLA sent by Kingroon for this print. Other than the stringing, the cooling and overhanging look okay. The bottom also looks much better after re-leveling the bed. Then I will print a calibration cube with the same filament. It turned out okay. The cooling is pretty good, the surface is clean, and the dimensions are also pretty accurate. Next, I will try some TPU. This Eryone TPU is the easiest to print TPU, and I can get a pretty good result even on a stock Ender 3, so I'm sure this Titan clone extruder can handle this as well. This Panda model is perfect. With a 15% infill, it's actually pretty squishy. Then, I will use VOXELPLA PLA Pro to print a snake or a Pokemon called Onix. However, before the first layer is complete, the extruder clogged, signal from the clicking sounds from the extruder. When I pulled out the filament, it actually grinds inside the extruder gear. Since the hot end is not clogged, I think this may be caused by the filament feeding angle. And the Bowden tube feels a bit tight when I try to pass the filament through, so this setup may not be able to provide the best filament feeding. So, I just used a few filament boxes to raise the spool holder to be taller than the print head and got rid of the reverse Bowden tube. The filament feeding seems much smoother now, so I will reprint the same model. With this new setup, the print was completed without any issues. The Onix model is printed pretty nicely, and the clearance is also good. After that, I will print a tougher model. This is a cat model with a hollow body and some patterns on the surface which requires an excessive amount of retraction. I will print this with Eryone Rainbow Silk PLA. This print turned out awesome. It's really beautiful and has no stringing at all. It's perfect from the top to the bottom. Next, I will try some PETG. I will print a scraper with Eryone $13 PETG. It turned out alright. Printing a model with a honeycomb pattern with PETG strings a bit more than what I would prefer, but it's still not too bad. Then, I will try printing with ABS to print a new filament holder that feeds from the top. When I tried to heat up the bed to 100 degrees Celsius, the printer stopped at 75 degrees Celsius and showed error 6. According to the user manual, this means a heat bed failure. I then lowered the temperature to 85 degrees Celsius so the print can start, but the temperature of the bed can only stay at around 80 degrees Celsius. This may be too low for ABS, but let's see how it prints. During the print, the temperature can't reach 85 degrees Celsius and stays in the low 80s. As you can see, the part warps a lot. Even with glue applied, it can't stick to the bed. Okay. Let's talk about the pros and cons of this printer with the stock setup, and I will talk about the upgrades later. So let's start with the pros. 1. Generally, you wouldn't expect a printer at this price point to come with linear rails, but this printer does. They run very smoothly, require less maintenance, and are more rigid than rubber wheels. However, Kingroon only put linear rails on the X and Z axis and not the Y axis. In fact, considering that the X and Y axis move faster and more frequently than the Z axis, if I had to choose just 2 out of 3 axes to apply linear rails to, I would choose the X and Y axis instead. They do have an upgrade kit for the Y axis, but I will talk more about this later. 2. The Titan clone extruder works well. It's a pretty standard off-the-shelf direct drive, and there isn't much to go wrong with it, especially when just printing at a regular speed at 50 to 60 millimeters per second. This 3-to-1 gear ratio extruder prints pretty well even with a single gear. 3. The assembly is easy. The Z-axis is a single 20 by 40 extrusion, and though it has 6 screws necessary to secure it to the base, it is more secure this way. 4. The build of this printer is solid. It's $30 more expensive than the old KP3S. The components of these two printers are very similar, but the KP3S Pro has a slightly larger 200 cube print volume, and the power supply is no longer detached and is now in the base and looks safer. So, I would say paying that extra $30 is reasonable. Now for the cons. 1. This printer has no auto bed leveling. Leveling a tiny bed like this is pretty easy, but the stock screen UI doesn't allow you to set the Z offset in real time. So, if the print is not sticking well, there's no way you can use the screen menu to adjust the nozzle height. The only option you have is stop the print, re-level the bed, and restart the print. Besides that, the screen UI doesn't have a preheat constant. When you need to preheat the nozzle to 200 degrees Celsius, you need to press the button 20 times. 2. The filament is detached, put on the table, and uses a reverse Bowden tube to guide the filament to the extruder. This may not be the best filament feeding angle, but the Prusa Mini uses the same feeding angle, and I had no problems with it. The reason may be the inner diameter of the reverse Bowden tube is too tight. All of these combined require more force from the extruder. The single gear Titan extruder should work just fine under a normal direct drive setup where the filament feeds from the top, but this extruder didn't work too well until I got rid of the reverse Bowden tube by using 3 filament boxes to raise it to get a better feeding angle. I also printed a filament holder and mounted it at the top, which makes the footprint more compact but will occupy more vertical space. 3. As linear rails are only available on the X and Z axis, there is an optional upgrade kit for the Y-axis, but the downside is you have to put the linear rails on top of the aluminum extrusions, resulting in a 15mm decrease in the Z height. 4. When printing ABS, I tried to heat up the bed to 100 degrees Celsius, but it failed. I tried to lower the temperature to 85 degrees Celsius, and the print finally started, but it could only retain around 80 to 83 degrees Celsius during the entire print. As the bed temperature is not high enough for ABS, it still won't stick even with glue applied. The issue was improved after I updated to the latest firmware. The printer can now heat up to around 95 degrees Celsius before the error message shows. As this printer has many possible upgrades, I decided to add a section in this video and talk about the upgrades I made and what issues I ran into. I decided on 2 3D printed parts. The first one you saw I printed is the filament holder. It allows you to feed filament from the top. I also moved the filament center to the extruder using a DuPont cable as an extension. The second is a handle at the back. As this printer uses linear rails on the Z-axis, the back is free to mod as you don't have the back plate like a rubber wheel motion system. I made a few iterations and was finally happy to settle for this one. For the print bed, I replaced the springs under the bed with some silicone spacers. For the print surface, I ended up still using the glass bed as the PEI sheet Kingroon sent is a smooth PEI, and I personally prefer textured PEI sheets. They also sent me a Y-axis linear rails upgrade kit, and I've installed them as well. After the kit was installed, the Z height was decreased by 15mm as the bed is now taller than the stock setup. The screw at the back used to trigger the limit switch is a bit off, so you need to set the Y limit switch position to -10mm inside the firmware config file to work as an offset. Otherwise, you won't be able to use the entire bed. So, if you want linear rails on all axes, instead of using the upgrade kit on this KP3S Pro, their new model, the KP3S Pro S1, has the exact same design, uses a lower 10x20 aluminum profile instead of a 20x20 profile on the Y-axis, and comes with linear rails by default. Hopefully, the new model is polished better than the upgrade kit. I also added a 3D Touch auto bed leveling sensor. Kingroon has the housing for you to print and mount the sensor on the side of the print head. Unfortunately, the MKS firmware config file doesn't have the option to use the bed leveling sensor for Z-homing, so you still need to use the mechanical limit switch to home the Z-axis and have to adjust the Z-limit switch to match the height of the bed, which is inconvenient. If you change the print surface from the glass bed to a PEI sheet, you need to adjust it again. This process can be avoided if the config file allowed you to use the leveling sensor for Z-homing, but I didn't see this option in the file. Another common issue on the MKS firmware with the BL Touch is, if you add G29 inside the G-code file and try to do auto bed leveling every time before the print starts, it won't print the purge on the side and will start the print immediately. This may result in the residue on the nozzle ruining the first layer of your print. The auto bed leveling is still functional and I can make it work, but using it on this buggy MKS motherboard and screen firmware requires some extra effort compared to a normal setup. Finally, I replaced the cable loom with some better quality ones, and instead of just using 2 pieces, I just ran all of the wires including the 3D Touch cable from the print head to the motherboard using 1 piece of cable loom, which looks much cleaner. In conclusion, the hardware of this printer is good, especially at this price point. If you just print with a stock setup, it works fine. The upgrade options kind of work but are not well polished. But after putting some extra effort into making all these upgrades, this tiny printer with all linear rails, auto bed leveling, and filament feeding from the top still looks pretty good and prints super nicely. If Kingroon can replace the MKS motherboard and screen with something else, or they have in-house software engineers who can debug the firmware and reprogram the screen UI, this machine should be able to work with auto bed leveling and make it a much better printer. That's pretty much all the experience I have with this printer. If you are interested in this KP3S Pro printer or the latest KP3S Pro S1 with all linear rails, I put the links under the description. That's it for this video. As I printed a few models after making all these upgrades, I will show the footage at the end of this video, and I will see you next time.